Probability of x is equal to 0 means the probability of the number less than or equal to 4 in both the tosses. The probability of x is equal to 0 means 6 does not appear at least once on any one of the die. The summation will give the mean, or it is also called as the expectation of the random variable x. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in my previous class, we have discussed regarding the problems based on probability distribution. Now, today also I am going to take few more problems based on probability distribution. Now, let us start with the first problem. This is very important problem for 5 marks. Find the probability distribution of the number of success in 2 toss of a die. So, we are tossing a die 2 times. Find the probability distribution of number of success in 2 toss of a die where a success is defined. How they have defined the success? That is, the number greater than 4 is the first case. 6 appears on at least one die and the number greater than 4. These are the 2 events given. Now, find the probability distribution for the number of success in 2 toss of a die where the success is defined as number greater than 4 in the first case and 6 appears on at least one die on the second case. Now, let us define x. Given a die is tossed 2 times. When a die is tossed 2 times, then the number of observation, the sample space will be 6 into 6, that's equal to 36. So, n of s is equal to 36. So, if a die is tossed 2 times, the possibilities, the observations we are going to get is n of s is equal to 6 into 6 is equal to 36 events. Now, let us define an event x. Let x is a random variable which represents the success. Now, let us define the event x as the success. So, that is, let x is a random variable which represents the number of success. Okay, x represents the number of success as the random variable. Now, the case 1, first one. Now, the number is greater than 4. Greater than 4. Now, that is probability, the cases, probability of x is equal to 0. Probability of x is equal to 0. Probability of x is equal to 0 means probability of the number less than or equal to 4 in both the tosses. Both the tosses. So, probability of x is equal to 0 means the probability of the number less than or equal to 4 in both the tosses. Number less than or equal to 4, since we are tossing twice, a die is tossing twice, the first condition, let us consider x is equal to 0 means the probability that the number less than or equal to 4, less than or equal to 4 in both the cases. Less than or equal to 4 means, so there are how many events? So 6 events. Number less than 4 means this is 4 by 6 into 4 by 6. That is nothing but 2 by 3 into 2 by 3. This is equal to 4 divided by 9. So therefore, probability of x is equal to 0 is equal to 4 by 9 is the first case. Okay. Now let us consider p of x is equal to 1. So p of x is equal to 1 means the probability that the number is less than or equal to 4 in the first case and greater than or equal to 4 in the second case, plus reverse. That is, p of x is equal to 1 means the probability of the number less than or equal to 4 in first toss into the number greater than or equal to 4 in the second toss plus the number, the probability of the number greater than or equal to 4 in the first toss into the number less than or equal to 4 in the second toss. This is the given condition. That's it. See here, probability of x is equal to 1 means probability of the number less than or equal to 4 in the first toss into the number less greater than or equal to 4 in the second toss plus probability of the number greater than or equal to 4 in the first toss into the number less than or equal to 4 in the second toss. So therefore this can be written as, I'll write here, that is probability of x is equal to 1 is equal to number less than or equal to 4 in the first toss is nothing but 4 by 6 into number greater than or equal to 4 in the second toss is nothing but 2 by 6 plus 2 by 6 into 4 by 6. So this can be written as 8 divided by 36 plus 8 divided by 36. This is equal to 8 plus 8 divided by 36, 16 divided by 36. Okay, this is the second answer. So if you want, you can also divide this. This is equal to 4 4s are 4 9s are 4 by 9. So listen to me, the case number 2. So when x is equal to 0, the probability that the number less than or equal to 4 in both the tosses, so that is 4 by 6 into 4 by 6 is 4 by 9. When x is equal to 1, the probability that the number less than or equal to 4 in first toss into number greater than or equal to 4 in the second toss plus reverse, the number greater than or equal to 4 in the first toss into the number less than or equal to 4 in the second toss. So that can be written as 4 by 6 into 2 by 4 plus 2 by 6 into 4 by 6, that is 8 by 36 plus 8 by 36, that is nothing but 36 LCM. 16 by 36 is 4 by 9. Okay. Now the third possibility, probability of x is equal to 2. Probability of x is equal to 2 means probability of the number greater than or equal to 4 in both the tosses. The probability of x is equal to 2 means the probability of the number greater than or equal to 4 in both the tosses. Number greater than or equal to 4 is nothing but 5 and 6, that is 2 by 6. 2 by 6 into 2 by 6. This is 1 by 3 into 1 by 3 is equal to 1 by 9. Therefore, probability of x is equal to 2 is 1 by 9. So, probability of x is equal to 1 is 4 by 9, x is equal to 2 is 1 by 9 and x is equal to 0 is, therefore, the probability distribution, therefore, the probability distribution for the first case is x and p of x. When x is equal to 0, x is equal to 1 and x is equal to 2, we have, when x is equal to 0, what is the answer? 4 by 9. This is 4 divided by 9. When x is equal to 1, it is 4 by 9 again, 4 by 9. And when x is equal to 2, it is 1 by 9. So this is the probability distribution for the first case. So 0, 4 by 9, 1, 4 by 9 and 2, 1 by 9. So if you want to verify, you can go for verification also. What is the verification? We know that sigma I is equal to 1 to n, pi is always equal to 1. Now add this sigma pi, this is, that is 4 by 9 plus 4 by 9 plus 1 by 9. Take LCM, 9 is the LCM, this is 4 plus 4 plus 1, 9 by 9 is equal to 1. That is verified. That's it. Okay, hope you followed. This is very important problem. So if you do this much, you will get 5 marks. This is 5 marks for first part. Second part also, you may expect for 3 marks or 5 marks. Okay, this is the first part. Now, come to the second part of the problem. What is the second part of the problem? 6 appears on at least one die. What is given? Given that 6 appears at least once on one die. Now, let us come to the second part. What is the second condition is, what is given? The 6 appears at least once on any one of the die. 6 appears, the number 6 appears at least once on any one of the die. Now, suppose let us consider P of x is equal to 0. X is equal to 0 means the probability of x is equal to 0 means probability of the 6 does not appears on any one of the die once. 6 does not appears. 6 does not appears. 6 does not appears at least once on any one of the die. So therefore does not appears means then probability of x is equal to 0. So this is equal to does not appear 6. 1, 2, 3, 4, 5. So therefore does not appears means this is 5 by 6 into 5 by 6. Since we are tossing a die twice, therefore 5 by 6 into 5 by 6, this is nothing but 25 divided by 36. So therefore probability of x is equal to 0 is 25 divided by 36 is the first case. Okay. Now come to the second part. Probability of x is equal to 1. That means probability of 6 appears at least once on the die. 6 appears at least once on the die. There are 3 possibilities. So if 6 appears and does not appear. So if 6 appears, then we have 1 by 6. If does not appears, it is 5 by 6. Again, in the first toss, 6 appears, whereas 6 does not appears, it is 5 by 6. Again, if the 6 appears in both the cases, 1 by 6 into 1 by 6. So 5 by 6 into 1 by 6 plus 1 by 6 into 5 by 6 plus 1 by 6 into 1 by 6. This is 5 by 36 plus 5 by 36 plus 1 by 36. Take LCM. 36 is the LCM. 5 plus 5 plus 5. 5 plus 5 plus 1 is equal to 11 by 36. Okay. Therefore, probability of x is equal to 2 is 11 divided by 36 is the second case. See here, this is very important concept. Now, P of x is equal to 1 means the probability that the 6 appears at least once on the die. So that is the case arise. Probable 6 does not appears means 5 by 6 into appears means 1 by 6 plus. First case 6 appears, in the second case it does not appears, 1 by 6 into 5 by 6 plus in both the cases if 6 appears, 1 by 6 into 1 by 6, that is 5 by 36 plus 5 by 36 plus 1 by 36, that's equal to 11 divided by 36. So therefore the probability distribution for the second, therefore the probability distribution, I'll write here, therefore the probability distribution is like this. When x is equal to 0 and x is equal to 1, P of x. So for x is equal to 0, it is 25 divided by 36. When x is equal to 1, sorry, this is not 2, this is x is equal to 1. For x is equal to 1, this is 11 divided by 36. This is the probability distribution. So when x is equal to 0, 25 by 36. When x is equal to 1, it is 11 by 36. So if you want to verify, you can verify sigma I is equal to 1 to n, pi is equal to 1. So here this is 25 by 36 plus 11 divided by 36. Take LCM, 36 is LCM, 25 plus 11 is 36 by 36 is equal to 1. So the answer is correct. Okay, this is the answer for the given problem. That's it. Okay, hope you followed this. This is very important problem, right? Now let us come to the next concept. The very important concept is mean of a random variable. Mean of a random variable. Now what is the mean of a random variable? So let x be a random variable whose possible values are x1, x2, x3, etc. The possible values of the random variable x are, let us consider it as x1, x2, x3, etc. xn, and occurs with the probabilities. The probabilities are p1, p2, p3, etc. pn. So that is for a random variable x, the possible values are x1, x2, x3, etc. xn, whereas the corresponding the probabilities are P1, P2, P3, etc., Pn respectively, then the mean of x is denoted as mu. Mu is the mean of this, and it's a number given by sigma I is equal to 1 to n xi into pi. That is nothing but x1 p1 plus x2 p2 etc. plus xn into pn. So that is nothing but the summation I is equal to 1 to n xi pi. That is the mean of x is weighted average of the possible values of x, each value being by its probability which it occurs. So therefore the mean of a random variable x is called the expectation of x. This is also called as expectation, and it is denoted as E of x. So in general, suppose if let x be a random variable whose possible values are x1, x2, x3, etc., xn occurs with the probabilities, the corresponding probabilities are p1, p2, p3, etc., pn, then the mean of x is denoted as E of x is equal to the mean. This is also called as the expectation of x, is given by the number mu is equal to sigma I is equal to 1 to n xi pi is the mean of x, is the weighted average of the possible values of x. Okay. Now, so thus E of x is equal to mu, that is equal to sigma I is equal to 1 to n xi pi is nothing but the summation x1 p1 plus x2 p2 plus x3 p3 etc. xn pn. This is very important formula. Thus the expectation or the mean mu or E of x is called the expectation of x, or mu is equal to sigma I is equal to 1 to n xi pi. Now, in other words, the mean or expectation of a random variable x is the sum of the products of all possible values of x by their respective probabilities. This is the important definition. In other words, the mean or expectation, the mean x or the expectation E of x of a random variable x is the sum of the products of all possible values of x and their corresponding respective probabilities. So E of x is equal to sigma I is equal to 1 to n into xi into pi. This is called the mean or expectation. That is nothing but the sum of all the products of all possible values of x and the corresponding probabilities. That is sigma I is equal to 1 to n xi into pi. The corresponding values of x and the possible probabilities. The summation will give the mean, or it is also called as the expectation of the random variable x. Okay. Now let us consider an example. If a pair of dice is thrown and the random variable x with the sum of the numbers that appears on the two dice, find the mean or expectation of x. See here, a pair of dice being thrown and the random variable x with the sum of the numbers that appears on the two dice. The sum of the numbers that appears on the two dice. Find the mean or expectation of x. This is the problem given. Let us write the sample space. The sample space of the experiment consists of 6 into 6. That's equal to 36 elementary events. So the sample space of the experiment consists of 6 into 6, that is 36 elementary events in the form of the ordered pair, because the sum of the two, what is given? The sum of the numbers that appears on the two dice is nothing but x comma y. The sum of x plus y. Okay. So therefore, the events of form and ordered pairs of the form xi, yi or x1, y1, where xi is equal to I is equal to 1, 2, 3, 4, 5, 6, and similarly for yi is also equal to 1, 2, 3, 4, 5, 6. Now, the random variable x is the sum of the numbers on the two dice, takes the values, it will take the values 1 plus 1. The first, if it is 1 comma 1, the sum is 1 plus 1 is 2. If it is 1 comma 2, it is 3. If it is 1 comma 2 comma 2, it is 4. So therefore the values of x, the random variable x, is the sum of the numbers of the two dice. So therefore x can take the values from 1 plus 1 is 2. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 12. The last number is 6 comma 6. Therefore it is 6 plus 6 is equal to 12. So it will take the values from 2 to 12. Okay, now let us come to the first. When x is equal to 2. When x is equal to 2. When x is equal to 2 means the probability of 1 and 1. So 1 and 1, that is nothing but 1 and 1, since the number of events, the total possible events are 36. So this is only one case will arise. So 1 by 36. When x is start from x is equal to 2, 3, 4, 5, 6 up to x is equal to 12. So let us come to this. When x is equal to 2, the first possibility is 1 comma 1. So 1 comma 1, that is 1 event divided by 36. The sum of the two numbers is 1 comma 1. 1 divided by 3. When x is equal to 3, the first number is 1 comma 2 and 2 comma 1. There are two events, 1 and 2, 2 divided by 36. When x is equal to 4, when x is equal to 4 means the sum is 4 here. The sum is 2, 1 plus 1 is 2 means only one possibility, 1 by 36. The sum is 3 means 1 plus 2 or 2 plus 1, it is 2 by 36. When x is equal to 4, the sum is 4 means 1 comma 3, 2 comma 2 and 3 comma 1, that is 1 plus 3, 2 plus 2, 3 plus 1, so 3 by 36. Similarly, when x is equal to 5, the possibilities are sum of the two numbers must be equal to 5. 1, 5, 2, 3, 3, 2, 4, 1, 1, 2, 3, 4 events, 4 divided by 36. X is equal to 6. If the sum is equal to 6 means, the sum of the two numbers is 6 means 1, 5, 5, 1, 2, 4, 4, 2, 3, 3. So that is 5 divided by 36. Similarly, if x is equal to 7, sum is equal to 7 means 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, 5 comma 2 and 6 comma 1, that is 6 by 36. Similarly, when p of x is equal to 8, x is equal to 8 means the sum is 8 means 2 comma 6, 6 comma 2, again 3 comma 5, 5 comma 3 and 4 comma 4. So that is totally 5 by 36. So these are the possibilities if the sum of the two numbers is 2, 3, 4, 5, 6, 7 and 8. This is the probability. Now when x is equal to 9, if x is equal to 9, what are the possibilities? So 3 comma 6, 3 plus 6 is 9, 6 plus 3 is also 9, 4 plus 5 and 5 plus 4, that is 4 by 36. Similarly, when x is equal to 10, the probability is equal to 4 comma 6, 5 comma 5, 6 comma 4 and 3 comma, that's equal to 3 by 36. When x is equal to 11, the sum is 11 means only 5, 6 and 6, 5. 6 plus 5 and 5 plus 6 is 11, that is 2 divided by 36. And when sum of the two numbers is 12 means there is only one possibility, that is 6 comma 6. Because 6 plus 6 is equal to 12, 1 divided by 36. So these are the probability distribution for x is equal to 2 to 12, that is the sum of the two numbers. This can be put in the form of a table. So therefore the probability distribution table is here x or x pi. So here it is from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So what are the values we got here? So here from the beginning we have, so 1, 2, 3, 4, 5, 6 by 36. Again in the reverse order, 5, 4, 3, 2 and 1. So first it is 1. So this is P of I, or this is also equal to P of Xi. So this is 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 divided by 36, again 6 divided by 36, again it is in the reverse order, 1 by 36, 2 by 36, 3 by 36, 4 by 36 and 5 by 36. So these are the values. Okay. Now let us find out the mean or expectation of this random variable. So now therefore the mean or expectation is given by E of x is equal to sigma I is equal to 1 to n, that is P of I into xi. Now simplify this. What is the answer we are going to get? If we simplify, this is equal to multiplied 2 into 1 by 36 plus 3 into 2 by 36 plus 4 into 3 by 36 plus 5 into 4 by 36 plus 6 into 5 by 36 plus 7 into 6 by 36, again 8 into 5 by 36 plus 9 into 4 by 36 plus, I will write here plus 10 into 3 by 36 plus 11 into 2 by 36 plus the last one is 12 into 1 by 36. So just multiply the summation. PIXI is nothing but 2 into 1 by 36 plus 3 into 2 by 36 etc. 12 into 1 by 36. So this can be written as, we can take 36 as the LCM in the denominator. In the numerator just multiply. This is 2 into 1 is 2. Again 3 into 2 is 6 plus 4 into 3 is 12 plus 5 into 4 is 20 plus 6 5s are 30 plus 7 6 are 6 into 5, 7 into 6 is 42 plus 8 into 5, 7 into 6 plus 40 plus 9 into 4 it is 36 plus 10 into 3 is 30 plus 11 into 2 is 22 plus 12. So this is totally equal to, so if you add you will get 252 divided by 36, this is equal to 7. The required answer is 7. So therefore the mean of the sum of the numbers that appears, the sum of the numbers if a die is thrown twice is 7. So the required answer is 7. That's it. Now let us come to the next problem, next concept. Now the next concept is the variance of a random variable, the variance. So let us define the definition. What is the definition for the variance of a random variable? Let x be the random variable whose possible values are x1, x2, as I explained in the previous concept. Let x be a random variable. The possible values of x are x1, x2, x3, etc. with their probabilities. The p1, p2, p3 are the probabilities. That is p of x1, p of x2, p of xn, etc. Then mu is equal to e of x with the mean of x. That is the variance of x is denoted as VAX, or it is also denoted as rho sigma x square. Sigma x square. V variance of x, or it is also denoted as sigma x square. This is the variance. That variance is given by summation I is equal to 1 to n xi minus mu whole square into p of xi. This is very important formula. That is, the variance is given by variance of x is equal to sigma x square is equal to I is equal to 1 to n xi minus mu whole square into p of xi, or it is also equivalent to sigma x square can also be written as e of x minus mu whole square. So the non-negative numbers, sigma x is equal to square root of variance, that is called the standard deviation. The non-negative value of the square root of the variance, that is called the standard deviation. Therefore the standard deviation is given by square root of variance of x. That is nothing but square root of this quantity. I is equal to 1 to n xi minus mu whole square into p of xi. So this is called the standard deviation. The standard deviation of the variance. So in other words, we can also calculate the standard deviation. Another formula to find the variance of the random variable is variance of x is equal to e of x square minus e of x whole square. This is another formula used to find the variance of x is also equal to expectation of x square minus expectation of x whole the square, where e of x square is nothing but e of x square. The expectation of x square is equal to sigma I is equal to 1 to n xi whole square into p of xi. This is what the expectation of x square. So to find the variance of the random variable, we are going to use the variance of x is equal to expectation of x square e of x square minus e of x whole square, where e of x square is nothing but sigma I is equal to 1 to n xi whole square into p of xi. So therefore the variance of the random variable is v of a or x. So whereas the square root of this sigma x, square root of the variance of x is called as the standard deviation. So here there are two concepts. One is the variance of a random variable and the standard deviation of a random variable. Now let us take a small example based on this variance and the standard deviation. Now let us come to this problem. Find the variance of the number obtained on the throw of an unbiased die. Now what is required to find the variance of the number obtained on the throw of an unbiased die. Now what is required to find is the variance. Just find out the variance of an unbiased throw of a die. Now the sample space of the experiment consists of the numbers from 1 to 6. So s is equal to 1 to 6. So n of s is equal to 6 here. Now let us denote x. Let x denote the number obtained on the throw. This x is the random variable which can take the values from 1, 2, 3, 4, 5 to 6. Let the sample space contains s is equal to 1, 2, 3, 4, 5, 6. That is n of s is equal to 6. Let us denote x as the number obtained on the throw, and then the possible values of x. X can take the values from 1, 2, 3, 4, 5 or 6. Okay. Now therefore what is the probability of, so therefore p of 1 is equal to 1 divided by 6, p of 2 is equal to 1 by 6. Similarly p of 3 is also equal to 1 by 6, p of 4 is also equal to 1 by 6, and p of 5 is equal to 1 by 6, and probability of 6 is also equal to 1 by 6, because here x can take the values from 1 to 6 and the sample space of the experiment contains 1 to 6. So p of 1 is 1 by 6 and p of 6 is also equal to 1 by 6. So therefore now the probability distribution of x is, therefore the probability distribution of the random variable x is, let us write x and p of x. What are the values of x? 1, 2, 3, 4, 5 and 6. Then what are the values of p of x we have? So here when x is equal to 1, p of x is 1 by 6, x is equal to 2, p of x is also 1 by 6, x is equal to 3, p of x is 1 by 6, when x is 4, p of x is 1 by 6, when x is 5, p of x is 1 by 6, when x is 6, p of x is 1 by 6. Okay, this is the probability distribution table for the random variable x. Okay. Now the expectation or the variance, what is required to find is the variance, the variance or the expectation. Therefore the variance or expectation is nothing but e of x. E of x is equal to sigma I is equal to 1 to n p of I into x of I. So what is the expectation? So e of x is equal to, I is equal to 1 to n p of I into x of I. So now let us write down, that is E of x is equal to sigma I is equal to 1 to n. You can also write like this, x of I into P of xi. So, E of x is equal to sigma I is equal to 1 to n x of I into P of x. Now, multiply this, that's all. What is xi here? 1. P of I is 1 by 6. 1 into 1 by 6 plus 2 into 1 by 6 plus 3. That is what we did in the previous problem. So, therefore, this can be written as, therefore, E of x is equal to 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So, just multiply 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So, this is nothing but 1 by 6 plus 2 by 6 plus 3 by 6 plus 4 by 6 plus 5 by 6 plus 6 by 6. Take LCM. 6 is the LCM. 1 plus 2 plus 3 plus 4 plus 5 plus 6. What is this equal to? 6 plus 4, 10 plus 5 is 15, 20, 21 divided by 6. 21 divided by 6. Therefore, E of x is equal to 21 divided by 6. Now, similarly, find out E of x square. Now, E of x square. Now, find out the value of E of x. So, again, this is square of this. 1 square into 1 by 6, 2 square. So, that is nothing but 1 square into 1 by 6 plus 2 square into 1 by 6 plus 3 square into 1 by 6 plus 4 square into 1 by 6 plus 5 square into 1 by 6 plus 6 square into 1 by 6. So, 1 by 6 is a common factor. We can take 1 by 6 out. So, 1 square is 1 plus 2 square is 4 plus 3 square is 9 plus 4 square is 16 plus 5 square is 25 plus 6 square is 36. So, if you add this 36 plus 25 plus 16 plus 9 plus 4 plus 1, this is totally equal to 91 divided by 6. So, this is equal to 91 by 6. Okay. So, E of x square is equal to 91 by 6. So, therefore, what is required to find is sigma x, yes, variance of x is equal to sigma x square minus sigma x whole the square. Variance of x or E of x square minus E of x whole the square. Therefore, the variance of x is given by E of x whole square minus Ex whole square. So, I will write here, what is E of x whole square? E of x whole square is 91 by 6 minus E of x is 21 divided by 6 whole the square. So, this is 91 by 6 minus 21 square. 21 into 21 is 444 divided by 36. So, you can take LCM and simplify this. Now, here, what is LCM? 36 is the LCM. So, 6 into 91 is 546 minus 441. This is equal to, so what is this equal to? 546 minus 441 is 105. 105 divided by 36. This is the required answer. So, if you want, you can also divide. This is also equal to 35 divided by 12. If you divide by 3, 3 3s are 9, 3 5s are 15, 3 1s are 3 2s are 35 by 12 is the required. So, therefore, the variance of x is 35 divided by 12. This is the required answer. Hope you followed this. So, just find out the value of E of x and then E of x square. So, the required answer variance of x is E of x whole square minus E of x whole the square. That is equal to 105 by 36 is nothing but 35 divided by 12 is the required. That is all for today's session. Let us meet with different problems in the next class. Thank you. Thank you very much.